Hi, we're going to take a look at grading this wonderful problem about sampling, and it is from the 2011 AP test, problem number 3. It's about an apartment building, and they're trying to figure out about carpet and about how to check for wear for carpet in apartments. Okay, they give you a diagram. Now they're never going to give you the diagram unless there's something very important that you need to notice about the diagram, and obviously it's really important to notice that children in the apartment is denoted by using that asterisk. For A, it says describe a process for selecting 8 different apartments using this method, and the method is saying use a cluster sample. All right, so that, remember, is an ice cream scoop sample. You choose a location and then you select everything in that location if there's other things in there. All right, so that is a cluster sample. So in this particular case, each floor can be its own cluster. All right, so if you pick a floor, you're scooping up every apartment that's there. So really what we want to do to be able to get 8 apartments, that corresponds to picking 2 floors. And that's sort of the way that they want you to go about doing this particular problem. So first step, label each floor with the numbers from 1 through 9, check, or say each floor is going to be represented by a number from 1 through 9. Okay, then you're going to write them on slips of paper. Okay, and you're going to put those identical slips of paper into a magic hat. Okay, so that's going to be your second check. Now this person that I'm grading for right here used a random number generator. There are alternate methods that work. The way that I've taught you is to use the magic hat, and we certainly can get full credit here. Random number generator, we're selecting 2 floors, okay, and so that's sort of the same thing as the magic hat, and the random takes care of the shaking, because that is our next thing that we're looking for, is the shaking. Check. So that using a random number generator is just a different strategy, but it still works. Okay, you need to make sure that you have without replacement. That is going to be another check. So we're up to 4 different checks going on right here. Now, you'll notice here using a random number generator, you can get a repeat on that too. And so what they're looking for that check without replacement, you have to, no matter what strategy that you use, you have to figure out how to get across how you're handling if a repeat occurs. And so that's what this person did. This person does have full credit on this particular problem. It's just different than the magic hat. And then the last check is going to be choosing 2 floors to get a total of 8 apartments. And so that's the last thing right here. You got to make sure that you're going to check and get 2 floors by drawing out two slips of paper without replacement. So there are 5 different checks right there. My person got 5 out of 5. All right, you check for you. Do you have all the little pieces to get full credit? All right. Did you use a cluster sample? You'll notice if you do something a little bit different, it probably not going to work out too well. They've set this up to be easily done using a cluster sample. All right, very much on purpose. Now B, it says, ooh, there is an alternative. And what they're introducing here is a confounding variable that they've tried to alert you to by drawing it in your picture with this asterisk. It's the whole kid thing. And so they propose an alternative sampling method using a stratified random sample. All right, stratified. That means that you're going to break up whatever you get into strata based on a very specific quality. Okay. In this case, they said they're going to break up the strata using apartments with children and the apartments with no children. So we have 2 different strata that we're working with, and then they're proposing you get a little bit from the apartments with children and a little bit of the apartments with no children, and they talk about the numbers 2 with and 6 without children. And it says in this context, what's an advantage of doing a stratified random sample? Now we know that stratifying, just like blocking, reduces the variability. That means you're going to get a better representative sample. Because no matter what, and you do it using stratified, one particular scenario would be 2 children, 6 without children apartments. Another group is going to be 2 children apartments, 6 without children apartments. That between the 2 samples, okay, and even if I do it again, all your samples are going to be based on 2 and 6. So there's not very much, or there's no variability between the samples. So that's why blocking and stratifying reduces variability. But the biggest thing about stratifying, the biggest key point here is that you're guaranteed a representative sample. That you know with what you get, you know you're going to have a little bit of everybody. Okay, and that's the advantage that we are going to cite within our writing. That using a stratified sampling technique, you're guaranteed a representative sample of some apartments with kids and some without. Whereas in a cluster sample, that might not happen. There are full floors right here that have no kids. Okay, like this floor, the 6th floor right here, and the 3rd floor. What if those were the 2 that we selected using the cluster sample? They don't have any kids, and that definitely is going to be some kind of confounding variable issue in this particular scenario. Okay, so what we want to do is look for that we are going to have a representative sample, and that we're guaranteeing that our sample has a little bit of both. So the stratified sample will work because there is a guarantee that the owner ran a test with apartments with and without children. All right, so what I'm doing is reading that last sentence right here. There's a guarantee that your sample is going to have carpets in the apartments with and without kids. So that is the first thing that you want to do. I would actually make sure that you talk about you're guaranteeing a representative sample, and that you can use the right vocab to really sort of push your justification. So that is the first check. Now the next check is, I think, a little bit harder to get, because it does say give one advantage, which we just did, and it also says in the context of this situation. So why do we want a representative sample? Why do we want to include the kids and the no kids apartment? So the next check is going to be that you have to make sure that you state very specifically that kids have different wear patterns on carpets. They're messier. They might ride their bicycles in the apartment. They do finger painting. They're messy. They're dirty, which makes that a confounding variable. So you need to make sure that you get that across. So let's see. This would be bad because kids tend to wear out carpets more than the adults. So there has to be a specific sort of scenario issue to solidify this particular answer. So got to say that, well, we're guaranteed a representative sample, but we also have to make sure that we expressly say that kids somehow treat carpets differently than adults, and that's why we need to include them. If that's not there, you're not going to get that check. So this is going to be worth 2 points, all right? And that means this total number of points is 7. My person got a perfect score on this particular problem. And that ends the grading for this particular problem.